Hello everyone, my name is Arturo Garcia, and today I am going to talk about my photosensor automation project for electromechanical systems. So for this project, our necessary materials will be number 1, breadboard circuit, number 2, breadboard jumper wires, number 3, power supply module, number 4, our photoresistor, which is our main component of this project, number 5, NPN transistor, 6, our LED bulb, 7, the 9-volt battery, 8, battery snap-on connector, 9, 100k ohm resistor, and number 10, 330 ohm resistor. What is a photoresistor? It is a light-dependent device most often used to indicate the presence or absence of light. Depending on what you need to power on, it can raise or lower its resistance to either power on the light or keep it off. So for instance, in this practical table, if you have sunlight coming in, then the light will be off. Now, if there is no daylight coming in, then the light will be on due to the low resistance of the photoresistor. Okay, so here we have our series circuit. So we have our 9-volt battery connected to the power module. And here you see our 330 ohm resistor in series with the LED bulb and in line with the photoresistor. So the reason why it's on is because the photoresistor is receiving light right now. But if you turn off the lights, the LED will slowly dim because of the high resistance of the photoresistor. But if you turn the lights back on, the LED bulb will turn back on due to the zero resistance of the photoresistor. And this is shown here with the flow of our current. So at nighttime, if we have the current coming from our battery through to the resistor into the LDR, at nighttime it will have such high resistance that it will not flow to the LED bulb. But during the daytime, our current will flow through to the resistor and through the LDR, because the LDR will have zero resistance or close to zero resistance, and the current will flow into our LED bulb to power it on and back to the battery. Okay, so here we have our parallel circuit. So here we have our 9-volt battery connected to the power module, and we have our resistor 330 ohm connected in parallel to the photoresistor and connected in parallel to the LED bulb. Now, right now it is simulating as if it is nighttime, so the LED is on. But if we shine a light directly on the photoresistor, you will see that the light will turn off. So the reason because of this is that in daylight you have the current flowing from the battery through to the resistor and directly through to the LDR, because the LDR has hardly no resistance, so the current is going to flow automatically to the photoresistor. Now if we do nighttime as it is simulating right now, the current is going to flow through to the resistor and to the LED to power it on. And the reason why it flows through to this path is because the LDR has such a high resistance, is that it will make the current go the other way instead of going to the LDR, therefore powering the LED bulb. So our final circuit is a circuit that includes a transistor. So our power supply is already connected. Our 330 ohm resistor is connected towards the LED bulb. We also have this black device, which is the transistor. We also included a 110 kilo ohm resistor connected to a jumper wire that's connected to one of the legs of the transistor, another jumper connected to ground, and the final jumper connected towards the LED to connect to the transistor. And here is our photosensor. Now here the light is off because the photosensor is being exposed to the light. But if you cover it, the light will turn on if I cover it with my finger. So the way this works is that in daylight, as we are in right now, the current will flow from the battery to the 100 kilo ohm resistor And since there is nearly zero resistance from the LDR, the current is going to flow directly to the LDR and back to the battery. There will be very little current going to the 330 ohm resistor and to the transistor, but it won't be enough to power on the bulb. Now at nighttime, or when I cover the photoresistor, the current is going to flow through to the first node and it will split. But here, if it goes down this path, when I cover the photoresistor, it will have such a high resistance that the current will just flow into the transistor. And this is where the transistor will act almost as a switch to help power on the LED, which will help move the current, more current back to the battery, but also help power the LED bulb as well, which is why it turned on when we covered the photoresistor. That concludes the end of my video. Thank you very much for watching.